Okay, so welcome to the massive open online course or Aspen Plus. So this is the live session and I find few participants over here. So I find here Tushar, Rahim, Krishna Venivel. So I welcome you. And here I don't find many learners in the YouTube chat. Okay, Hemal Parulekar. Yeah, thank you, Hemal. I'm fine. Good afternoon. Kunal Shirke, good afternoon. Okay, so you can ask me questions, whatever you have doubts about your recent, you have attended the course so far. You can ask me questions. Yeah, Yasir Azam, good afternoon. Shamhira Khatun, good noon. Shekhar Yadav, good afternoon. Shashi Kumar, Balu, good noon. Purnatoya Subudhi, good afternoon. Rahul, hello. Ultra Giant, oh, good afternoon. Poojan Parik, good afternoon. Window of the Future, good afternoon. Good evening, okay. So probably it is evening at the place where you reside. So good evening. Maybe you are in somewhere in Australia or so. Who else? Okay, guys, you can ask me questions. Ash King, Karthik Zade. Good afternoon. Okay, Karthik, assignment 3, you have some questions. And what is the question? Acetone, ketene, methane, vapor cracking. Well, don't ask me some question in cryptic language. Please ask the question in a very plain and simple manner. Type it, or if you can come online through Teams Live and you can ask me questions directly. Apparently, Kunal is having some problem with assignment 3. Okay, let me check what is assignment 3 first. For that, let me open the assignment file. Yeah, assignment 3 is in front of me. Okay, so yeah, Shamira, actually I'm not able to understand your question. You are writing some acetone, ketene, methane, vapor cracking, NRTL, HOC using Unifac. So what is your question, Shamira Khatun? You have to ask me in proper language. Hemal is asking, sir, can you explain the simulation process of exchangers in short? I have already discussed. I mean, if you have any doubt, you can ask me. Otherwise, I can give a copy of the lecture that I have given over here. Sohail Khan, I didn't get the Aspen software. How can I get an installed Aspen Plus? Okay. Sohail and probably others also, I can show you what exactly you have to do for that. Let me open the 1 minute. So Sohail, where is that? Yeah, Sohail Khan and others who did not get the Aspen software, you may please look at the forum. I have just opened the forum for you. So this is the forum, and on February 13th, we have sent one email where you can see the links to download. Now, many of you are having problem with the Google Drive. So many of you are facing the problem that you are not able to download it from Google Drive. So we have given an installation document in our IITG server. So in IITG server, if you click this link to the email on 13th of February, if you click it, then you can see you will arrive over here. Okay. So you will arrive at IITG server. Then you can click over here, and then you will see the Aspen v14-ing.zip zip file, which is around 15.19 GB. Okay, so this huge file will be downloaded. So it will directly be downloaded from IITG server. So you can download them, and then you can download this file directly from IITG server. You do not have to depend upon Google. Now what you need to do is you need to go to the zip file, and in that zip file, if you unzip that file, then you will get a folder of this sort. Okay, so there will be a folder of this sort where you will get a setup.exe file and many other files. Now, if you open this file, Aspen Plus v14 installation procedure.pdf, then you will find the entire installation procedure. So you can install the software over there. Now, how to install? You have to, although it is written in the installation procedure, but I can tell you in short that you can double click this setup.exe, and then you follow the instructions. But you have to remember that your computer has to be up to date, because there are some prerequisites which will be told to you while you install. There are certain Microsoft files which are to be downloaded from Microsoft website, and you need to install them before Aspen Plus can be installed fully. Okay. So you need to install the prerequisite first, and then you have to install this Aspen Plus software. And once you do it, then you can use it. Only bottleneck that you may face, that is the licensing, because many a times I have told you, but still people do not understand. They still keep me asking these questions. The license problem. Okay, now the license problem you may face because we have a limitation of 150 licenses. So maximum 150 parallel learners can access the Aspen Plus software. So unless you are one of the lucky 151 people, you will not be able to access Aspen Plus software. So you have to be very careful about it. Um, so in the regular hours, like afternoon or late evening, you may not get the access to the software because many people will be trying to access the software. Okay, so 150 license may be taken up. But if you try to access the license sometime around, say, morning, early morning, okay, or late night, then you can access the software very easily. You will be one of the lucky 150 persons who will be able to access the software. Okay, so that is how you install and access the software without any licensing problem. Okay, fine. So now I take the next question. It is by, so Sohail, I believe you have, you know what I wanted, you know how to install the software, okay? So Ash King is asking, sir, is the Aspen Plus version we downloaded will be valid till which date? Actually, I have prepared the video on the basis of Aspen Plus 11 a few years back. Now, within 3-4 years, the version has gone from 11 to 12, 12 to 12.1. Now Aspen Plus version 14 is running. Okay, so all the questions that I have asked in the assignment as well as in the final test I'll be asking, all those questions are based on Aspen Plus version 14. And this version 14 will be valid till, I mean, it will go on for a few years. As far as your course is concerned, this course will end sometime in April. So you'll be sure that by the time you finish this learning this course, this Aspen Plus version 14 will be valid. In fact, some of you have downloaded version 12. They are also valid. I mean, those who have downloaded version 12, they are also able to use the software without any problem. Okay, so version validity is not an issue. Ash King, be sure that it is not an issue. Okay, Pujan Parik is asking, sir, suppose task is given to calculate density at particular temperature, can we calculate without introducing any model equipment? Yes, you can go and do it in your property analysis. Okay, in property analysis, you can find the density at a particular temperature. For instance, if you go, I will open the file and show you. So for that, you have to go to properties. Okay, properties. And there, suppose we have over here properties, water and butanol. Okay, suppose you want to find out the density of water. So what you need to do, you need to take pure, okay, pure analysis. So here there are various property methods. say thermodynamic, transport, all US alpha function test. Now this comes under transport. So you have to find out the density, right? For density, you have to check rho, density of a pure component. Okay. So, and here you have to say you take grams per cc, okay, or kg per meter cube, whatever. Now grams per cc, you know, water density at 0 degree centigrade is 1 gram per cc, right? So let us check. Phase is liquid and say water. So select water. Pressure 1 atmosphere. Choose 1 atmosphere pressure. And list of values, you can say 0 degree centigrade. Okay. So water, density of water, liquid phase at 0 degree centigrade, 1 atmosphere pressure, run analysis. Okay, so you can see it is written as slightly more than 1.003 or so. Now I remember it is not 0 degree centigrade. There is something called anomalous behavior. I think it is 4 degree centigrade, right? As far as I remember, it is 4 degree centigrade. So if you check at 4 degree centigrade, I believe we will get it at sorry, I have some mobile. Okay. At 4 degree centigrade, if you run the analysis, yeah, now you can see at 4 degree centigrade is near to 1 grams per cc. Okay, somewhere here. So I think it is 4.11. If you do, it will come exactly at 1 grams per cc. So that's how you can run the property analysis, and you can, without any equipment also, you can find out. Okay. So.
Hello, sir.
Yes, Pujan Parikh.
Yes, sir.
Did I answer your question, Pujan?
Yes, sir, you did answer. Sir, but can't we get any digital, like, a precise value?
Sorry?
In here we need to infer this value from graph, right? So.
Okay. So probably you, yeah, it is graph. So you can, what you can do, you can give a range of values. So starting value 0 degree centigrade and ending value 100. So you can run it from say -10 to +10, say +10 degrees centigrade with an interval of 50. And you can run the analysis. Oh, I am not sharing it. Is okay. I forgot to share. Okay, so this is the graph. What I did here, I did it from -10 to +10 with 50 number of intervals. Okay, so I ran the analysis and I got this one. So you can see, you can, I think, it is possible for you to, yeah, zoom. So, yeah, view. So somewhere here. So this is the point, you know, probably. So 1 grams per cc will be somewhere here. So it is 9.21 degrees centigrade. That's what it says. I'm not sure how much it is true. It should be true because Aspen Plus is, you know, getting it from its own database. Obviously, there are NRTL property method you are using, but if you use, say, if you use ideal property method, I think that will be better. Okay. Suppose you do ideal property method, and then you go to the pure component analysis, and instead of NRTL, you put ideal, and then do run the analysis. Then I believe you can get a better, reliable result. There will be a slight difference, you know. See, it has gone to 0.99. Not much difference though, somewhere here. Okay. So that we have to accept for liquid row, row of liquid water. Okay. So that's how the things work, you know, in Aspen Plus. That's how the things work.
Good evening, sir.
Yeah, Tushar.
Yes, sir. I would like to ask you a question related to assignment 3.
Okay, assignment 3. Tell me.
Sir, in this assignment 3, the first part, it is a reaction between ethanol and acetic acid. So when I am selecting the, when I am running the simulation for batch reaction, and the stop criteria is 0.308 moles of ethyl acetate, I am getting the operation time as 1.3 seconds.
Sorry, what is your question?
Sir, that's what, sir, actually the answer is given as 1.21 seconds. I have run it in my, yeah, assignment 3.
Assignment 3 what?
Assignment 3, sir, first part. First part.
Part A.
Part A. In that, sir, question number 4. Missing value Z as indicated by in figure 7 is dash seconds.
Right.
So as per, if you directly look at the graph, you can make out that it is between 1.2 and 1.25.
Right.
But obviously we have to do simulation also.
No.
Not by just looking at the graph, correct?
No,
so when I did the simulation,
I didn't ask you to do simulation.
Sir,
see, part A means you can answer the question without doing any simulation. In fact, you will do the simulation. Have I given you the complete complete information about the problem the way I have done it in part B?
No, sir.
In part B, I have given you complete information so that you can perform a simulation. But in part A, I have not given you any information. I have given you part information, and I have given you only that much of information which is needed for you to solve the question number 1 to 5. So for part A, you do not need any software. For part A, for answering part A, the question and the given table or figure, they are enough for you to answer part A. You don't have to do any simulation. Okay. Okay, so I
Good
hope
evening,
it's clear.
sir.
Sorry?
Good evening, sir.
Yeah, Krishnaveni.
Professor. Yeah. So first, thank you, sir. Thank you very much for teaching us the course, the software.
Welcome.
Sir, I'm a chemist, so I'm a doctorate student in chemist. So I have to know the basics of chemical engineering to work on the software. Could you please suggest a book for me? Because the software is completely new to me. I'm a PhD. I did my PhD in chemistry. Now I'm doing my postdoctorate. Now I have to work with the software to do my postdoctoral work, research work, but I'm completely new to the software. So I have to learn some basics in chemical engineering aspects as well as some basics in Aspen plus software. So could you please suggest any book to me to learn?
Okay, sorry, madam, actually, chemical engineering is a 4-year course. And no matter which book I suggest, it will not be possible for you to cover the entire chemical engineering by just reading that way.
To know some basics,
so, ideally,
some essential basics to run the software.
No, it is not possible, madam. You have to be a chemical engineer to understand what I am teaching. That is the problem. Many people come here and do the course thinking that they will understand everything, but it is very, very difficult for non-chemical engineers. Probably you can somehow manage the course by solving the problem, and somehow you can get a certificate, but that will not be of any use for you, other than just putting something in your CV. First, let me please understand this fact that chemical engineering is a 4-year degree course. I accept the fact that you are a chemist and you have good knowledge in chemistry. So there are certain areas of overlap between you and us, the chemical engineers. There are quite a portion of overlap. I agree that. But in the course, I will talk about the distillation column, the exchanger, heat exchanger. We'll talk about the reactor. And I believe that there are so many engineering aspects to these things which cannot be learned just by reading a book. Okay, so even there are certain universities which offer courses of applied chemistry in the form of as a substitute of chemical engineering. But even there, people, after doing 3 years of BSc in chemistry, they do 3 years in BTech in chemical
Okay.
engineering. So they do complete 6 years of studies. So how can I suggest a book by reading which you can learn or you can understand the subject that I am teaching? So you are in a wrong course. I may be harsh to say that, but you are in a wrong course. This course is not for you. Probably you can use this for property analysis and all, only that much, because
Okay.
in just a few minutes back when I was teaching it to Pujan Chirag Parikh, he was asking me how to find out the density of some material. I just showed you how to do it. Probably you have followed that. So
Yes, Professor.
you can find out the density of some material, if there is a mixture of two individual component, how to find density, how to find entropy, enthalpy, these, that. All those thermodynamic analysis or transport analysis, those probably you can do. But the moment it comes to simulation, then you will have all those equipments, their combination. There will be an exchanger, there will be a pump, there will be a compressor. Okay, and each and every
Yes.
unit of this, they are a subject by themselves, So really, it is not possible for one
Okay,
person
sir,
just
I
to read
understand.
those and understand the subject. Okay, so I'm sorry to say, but this is how it is.
I understand, sir, but for doing my postdoctorate for the next 2 years, I have to work on the software for my research work for the simulation process. So it would be good if I learned something from the textbook, not just to know all the model palette, some basics to run the software. Of course, I understand it's so difficult to us because we are not a chemical engineering student, but at the same time, we have to work on the software. So that's why I'm trying to learn something from the course.
Okay, you may try. I can wish you all the best. What can I say?
Thank you, Professor.
Okay.
Hello, sir.
Yes, Pujan again. Yeah.
Sir, I have one more question, that while designing a reactor, we need to input what exactly is the phase of the material. Like, is it vapor? Either it is liquid or vapor liquid. So how can we know whether it is vapor or liquid? We don't know that at particular this temperature, the fluid will be in vapor phase or liquid phase. So how can we judge that?
You cannot judge that, but you can give an idea. No, this is a vapor liquid system. I mean, whether it is vapor or liquid, you do not know, but it is a vapor liquid system that you know, right? Or if it is a completely liquid system, that you know. For instance, if the temperature of water is 100 or 250 degrees centigrade, and it is 1 atmosphere pressure,
Okay, sir.
you really cannot take it as a solid material and work, right?
Yes.
So that much of idea one should have. Otherwise, any software in this world is a junk in and junk out. Because software is not a magic thing. You are the engineer, you are the learned person, so you have to feed in the data or the condition which is logical. Then only the software can work on that. Otherwise, if you give any junk value, it will calculate some junk output and give you. So you cannot say that I do not know anything about anything. I want the software to solve my problem. So there should be some basic knowledge about what exactly you are working with.
Okay, sir. So my question was, suppose temperature of water is given like 115 degrees. Pressure is given as 5 atm pressure. Now, using this condition, can we judge the phase of water, like whether it will be liquid or in gas phase?
Yeah, so you go and take it as a vapor liquid phase, because the phases come in combination, whether vapor liquid or two liquid LL, it may be VLE, VLLE, right? If there are two immiscible liquids are there, then it will be LL, isn't it? Vapor, liquid, liquid equilibrium.
Yes, sir.
So you have to choose the proper VLE, and then you can do the property data analysis the way I have showed you, the density or whatever the property you want to judge. And then you will get some result, some graph, and from that graph you can get an idea, isn't it?
Yes, sir. Okay, that's all. Thank you.
Yeah. Okay, let us take some questions from the YouTubers. Yeah, Shamhira Khatun, assignment number 3, problem 6 to 10. Okay, let me check what she is talking about. Problem 6 to 10. Oh, so she talks about the vapor phase cracking of acetone. Okay, so Samira, I understand what you are talking about, but then what is your question that you have not said? Window of Future is asking, sir, how to check conversation with respect to length. Conversation with respect to length.
I think he means conversion.
Conversion with respect to length means? Did you understand what he wanted to say, Pujan or Tushar? Who said? Okay, whoever. His question is not clear actually. I'm not able to understand. Okay, Karthik Jadai sir is the, yeah, Pujan.
Sir, there was one question that what is the conversion at 2 meter length of PFR? So might be wants to know the solution for the same.
Where is the which question it is? Anyway, let him come back with the proper question, then only I can ask. Anyway, so the next question by Karthik Jade, he is saying, sir, is the pressure of batch reactor, should we assume? Is the pressure of batch reactor at assignment number 3, part 1. Batch reactor, you assume pressure. I don't know exactly what is his. Probably he is asking whether he has to assume the pressure of batch reactor. In fact, Karthik, although I don't understand your question completely, but one thing I must inform you that part A, all the answers are there in the question itself, either in the question or in the figures and tables. So whatever the figures and tables you have, you do not have to assume anything. That all the informations are there, and you can answer the question without any assumption. Rebuilding me is saying I am facing issue in download. Okay, I have already explained in the beginning of this session. Sir, is that what is difference between Aspen Plus Plus and Aspen HiSys? These are two different softwares. Kunal Shirke is asking, sir, please solve week 3 assignment part B. Assignment 3 part B, I don't know whether probably, is it over? I mean, are you able to check the answers of assignment part B, week 3?
Yes,
We
sir.
received the answer.
You have received the answer?
Yes, yes.
Okay. Okay, then I can show you. But before that, let me check any other question. Before that, okay, Nani123 is also asking the same thing. Hemal Parulkar is saying, I have already downloaded version 12 from NPTEL team. Do I have to delete it before downloading V14 version? You do not need to delete anything, Hemal. You can continue with that. Bhaskar is saying how to get process intensify equipments like reactive distillation, membrane reactor. No, Bhaskar, these are the things which reactive distillation is possible, but membrane reactor is not. Reactive distillation means you have to add some reaction component in the regular rat frac column, Bhaskar. So that it is possible, but membrane is not there. Membrane you have to write your own model. Then Karthik is asking about some separation of hydrofuran from water. You have to check the property database. I'm adding enzymes component, but it's not working, showing warnings. Nani123, adding enzymes. What enzymes component? Forget it. Sohel Nadaf, sir, please start Aspen HiSys EDR dynamic. HiSys I will show later. Karthik ji is asking solid gas reaction, what is property method used? Solid gas reaction. Property method, solid property. I have not taught solid for that matter. Please limit your questions to whatever I have done in the basic course, okay? Anumadla Rohit, input part, I have doubt in the second part of assignment 3, okay? I am going to show you. Kunal Sirke is asking, okay. Okay, so these are the questions of YouTubers. And before going to assignment, I want to check the questions asked over here. So okay. So here Dharmesh Adinath More is asking, sir, I want to ask question about Aspen version 12. I am unable to understand how to create a project or new simulation. New project or new simulation. Well, Dharmesh, you have to see my first few videos. I have already said everything about it. You know, I mean, this is the basics of new simulation, how to start. Ayush Chaubey is asking, sir, the interface in your software that are be different from our software interface, how we can operate in the same as yours? Ayush, interface is not that different. I understand the because I prepared the videos with Aspen Plus version 11, and now version 14 is running. So the interface is somewhat similar. If you have version Aspen version 8 or something before, then obviously the interface has changed a lot, because Aspen version 8 or so, their interface was completely different. Okay. So I do not know which software you are having, but as far as this course is concerned, I want you to download version 14 and learn it. Khairul Hassan is saying, I am unable to download. Okay, I have already discussed how it is done. Then Nayan Bari is asking, version 14. Okay, he is writing many things in block letter. Nayan, already I have discussed. Probably if you have gone through, I have given a NPTEL server of IIT Guwahati. From there you can download. Okay. Prakash Shivappa is asking, future of Java language in Android development. I am not a software developer, Prakash, so sorry, I cannot answer your question. Okay, now I will show you the assignment. Okay, for that, let me open the assignment 3. Okay. Okay, so is my entire screen visible to you all?
Yes, sir.
Okay. So you can see, so this is the assignment 3. Vapor phase cracking of acetone is taking place inside an adiabatic PFR of length 10, diameter 1. Reaction is as follows. The reaction first order, all those information are given. Anyway, so there are 3 things. One is acetone, then C2H2O and CH4. So we just go to the component. You have acetone, and then methane, and then ketene. Okay, so these 3 components we have chosen in components. And then we take the method filter chemical and base method NRTL HOC. So I have taken that way, and the base method is NRTL HOC under method filter chemical. Okay, and then we run it. Suppose we run it. Okay, and you have to estimate the binary interaction parameter NRTL1 using unifac method. So here you find NRTL1, right? So NRTL1 you have to estimate using unifac method with tick, right? So that way your property database is done. Then go to simulation, and this is a PFR. So I have brought a PFR over here, and the PFR length. So go to PFR, the setup. So this is R plug, okay? So its configuration you can check. The length is 10 meter and diameter is 1. And what else? It is vapor phase cracking. I have said it is vapor phase cracking of acetone. So the valid phase is vapor only, right? So we don't. So somebody was asking, I think Poojan was asking, which one we have to use. Now here we have vapor only or vapor only phase, right? It is the vapor phase cracking, right? If you do liquid phase reaction, then you have to say liquid only, or vapor liquid, vapor liquid, liquid. There are many options, so you have to choose wisely. So that is what is required, okay? And then reaction is first order with respect to acetone with rate constant K and activation energy values given over here. So in the reaction, this is R1. I have put the reaction over here. So this is the reaction from acetone to ketene and methane. Acetone to ketene and methane. In the kinetics, the reacting phase is vapor. And here you can see the K value is 8.2 10 to the power 14. And this is 284,522 kilojoule per kilomole. So this we have given. And CI basis is molarity. So all those informations are given, right? What else is left? Okay, the feed. So feed is this one. And feed is 8,000 kg per hour mass flow, which is acetone. So only acetone is going in. Temperature is 600 K, pressure 2 atmosphere. Feed is passed through a heater. Okay, so did I give heater? Yeah, this is the heater. And heater, it attains a temperature of 1035 K with no pressure drop. So pressure drop is 0. Answer the following 5 questions with accuracy up to 3 digits. So with that, we can run the system and we can see what are the answers. So answers are mole fraction of acetone in PFR at length 2 meter, right? So just go to profiles. Okay, so here in B1, you see profile, mole fraction of acetone at the length 2 meters. So it's a 10 meter length, 10 meter long reactor at 2 meter. What is the mole fraction of acetone, right? So molar composition. Molar composition of acetone at 2 meter length, it is 0.664609. So it is within this range. Okay. Then mass flow of acetone in the product stream. For that, what is the product is S2, right? So S2, you can see the streams S2 over here. What is that? Mass flow of acetone. Mass flow of acetone. So this is the mass flow of acetone kg per minute. So you just put it in kg per minute. 97.99. Okay, so within this range. Okay. The temperature of outlet stream. Temperature of outlet stream S2 in degree Fahrenheit. 1127. Okay, so it is within this range. Residence time of PFR. So residence time, again, you have to go to the results of B1. Residence time in second, right? So just convert into second, 4.51 seconds. So it is within this range. And heat duty of PFR is 0. Okay, this is 0. So that's how you solve your problem. So did I show it properly? Who asked this question? I think yeah, Nani 123. And also someone else asked, Anumadla Rohit also asked this question, right? Yeah, so these are the things that I have added now. Nani 123 is added new component pyruvate imported mole file. I'm sorry, Nani, I'm not able to understand your question. You have to write it in a proper manner, okay? Okay, Augusta, thank you. We have understood. Okay, Pujan is asking, sir, how? Okay, what is your question, Pujan? It went off. How can we decide free water method? Well, free water method, there is nothing to decide. Actually, free water method means if your system is having lot of free water component, you may want to take a kind of decantation of water. You know, you want to get that water out of the system. So that and that part of water is not taking part in any kind of reaction or any kind of it's not in use in the system, so that you can use that you can take it as a free water method. Okay. How to determine which convergence algorithm a particular block is using? How to determine which convergence algorithm? Okay. Convergence algorithm, for that you have to go to this convergence. So you have to go to this convergence, okay? In the simulation panel, here you will find below reaction. Below reaction, there is something called convergence, okay? So here, if you put in convergence, their default methods are given. So default convergence methods are these. for tiering stream, we use Wexten, single design spec, we use second, multiple design spec, Broiden, tiered and design Broiden. Optimization is sequential quadratic programming, SQP. So these are the methods. Now you are asking some questions which are actually done by the advanced users. So I do not know whether already you know this, what they mean. So if you know, probably I can explain you offline. But this course is for basic users, you know, so this part will be a bit tough for them. So let us keep it aside. You can change. I mean, in a very short way, I can explain. You can change it as you wish. So there are Wexten method, direct method, Broiden method, Newton method. Now here in the multiple design spec, they use Broiden or Newton. Here there are 4 options. Here there are 3 options. For optimization, there are complex options as well. So you can choose if you know exactly what you want to do with your simulation, you can choose it properly. Otherwise, it is best to keep it as default, you know, because the software programmers, they have written the code with something in their mind. So until unless you know exactly what you are doing, it is best to keep it as convergence, as a default convergence method, not to do any test on that. Okay, so already it is 6 minutes past 4 o'clock. So if you have any more question, we can spend another couple of minutes or so maximum. After that, we can close this session. Yeah, Kunal, you have raised your hand and we have not taken any question from you. You can ask if you want, Kunal Gupta.
So you just answered my question, convergent question.
Sorry, I didn't get you. Did I ask? Did I answer your question?
This convergence algorithm.
Oh, okay. Yes, Kunal. Okay, thank you. Okay, probably I can conclude this session with thanks to you all for coming to this session and discussing with me. Okay, so there will be another couple of live sessions where I will come in the later part of this course. So keep learning. Okay. Thank you all.
Thank you, sir.
Thank you, sir.
Okay. Goodbye. NPTEL, you can close this session.